So the other button, the CDF button, C means cumulative. So it's everything accumulated up to that point. So CDF always means less than or equal to. So if we can reduce a problem to being a less than or equal to, it's a whole lot easier to write it as a CDF instead of a PDF. And I'm going to make you write these out a little bit more than you might think you would need to, but I'm showing you why. So all of these still apply. What do I have? E through G on the side. Like I would just do this and write binomial. What? Okay. Then with these two, so that you're showing, if this were a real problem, I would still have to write that off to the side. It's just still all the same, so I have written it off to the side. So, did I skip something? Maybe I did it with a different problem. I did it with a different problem. What is the least amount of switches that could fail? What's the most? How many trials am I doing? Sorry, not looking at this. In general, with the context of this, 0 to 10. And this, what I'm writing out, is my thought process. And some of you are going to use this and some of you aren't. That's fine. So, which numbers do I want? Which numbers are at most 4? So this is a really easy one to do. So I can write that as P parentheses X what? And that's the way I want it to be able to use CDF. So at this point, CDF is taking all of your X equals 0, X equals 1, X equals 2, X equals 3, X equals 4, and doing what with them? Just adding them all up. So we definitely know that it's going to be bigger than these two added together because we're also adding in a couple more. So second distribution, binomial CDF, trials is 10, probability is 0.1. Your X value, the one that you're going up to, is 4. And you get what? So if I want ones, I just said find the probability. I wanted to show you something. If you want to like switch these like that, I want to show you what your answer choice would look like on a test or something. It would be something like what's 0.1 to the 0, 0.9 to the 10. So like that's my one for X equals 0, right? And it would do plus and 0.9 to the. That is a common answer choice that you would see on the AP exam. So it would say, I'm taking everything from here to here and adding it up, and it would not write them all out. Again, I never need to see you write that on the test. You would only need to know it that way if I gave you answer choices and that was one of them. So I got ahead of myself. All right, so this is the question that I just asked you. That's not what I just asked you. Oh, my different problem. I spaced yours out a whole lot different after I saw how much room it's going to take. Okay, so 7-sided die has a star on 3 sides of it. and the rest sides are blank. Really quick, check that it is a binomial distribution. So check all 4 things real quick. When I say check all 4 things, I mean check the what? Spins. It goes with what's below it. Sorry, all of my problems underneath say we're rolling it 7 times. Up there, you might want to write roll it 7 times. All right, now I'm rushing you a little bit time-wise. What do I write beside a binomial? Or what? Star, not star, star, not. Just making sure that you're saying, hey, I checked 2 outcomes. It was star, and the other one was something else. What do I write beside an independent? What's my next thing to check? What do I write there? And what's my last one? Oh, yes, binomial. So we're going to answer A and B, but we're going to answer it twice, so I'm not going to write it there. What is the fewest number of stars I could get if I roll the die 7 times? 0. So this is what I was just talking about when I actually wrote it out earlier for the other problem. It'll make more sense tomorrow when I write that.
It would have been less than 1.
When I was asking that, yeah. So now in this one, if I roll it 7 times, what's the most number of stars I could get? Right, I've got 7 times the number of successes I can get. That should be very, very basic. That is written out on purpose. So let's say let n be the number of stars. So I can write this into a probability distribution. So based off of what you just told me, what's going to go right here? What number is going to go right there? 0, all the way through 7. How do I find the probability of it being 7 or being 0 successes? Probability of x equals 0. So the second distribution, probability is, you can literally write 3 divided by 7 as your p. I need everybody to do this with me because I'm going to show you how to kind of shorthand stuff once we've done it. So second distribution, binomial PDF, your n is what? Or your trials is what? 7. Your p is what? 3 out of 7. And then for right now, you're typing in x is 0. And you get what?
0.
What's going to happen with a lot of these problems is I'm going to give you one scenario and you're going to find that answer for a bunch of different x's, right? So instead of going back and starting all over, if you hit second enter, it drops down what you just typed in, which was binomial PDF 7, comma 3 out of 7, comma 0, and just go back 1 and change that 0 to a 1 instead of starting all over. So you do second enter, it shows you where you type. Literally click back to the left 1 to change the 0 to 1 and hit enter again. And now you get what?
0.1044.
I do it again for 2. Second enter, change the 1 to a 2. And I get what?
0.2350.
What's happening to these probabilities right now? They're getting bigger. What do you get for 3? 0.2938, still getting bigger. What do you get for 4? Am I still getting bigger? So let's stop and think about this. It peaked here. Before you ever walked into this class, if I said, I'm going to roll this 7-sided die 7 times and 3 out of the 7 sides are a star, and you had to guess how many of them would be a star if I rolled it 7 times, what would your guess be? Probably 3. Why? If you flip the coin 100 times, how many would you expect, how many would you guess would be tails? So how do you figure that out? Half of what? The 100 would be my what? And the half would be my... So our n here was 7. Our probability was 3 out of 7, which gives us 3. That's tomorrow, but you showed me that you know what it is through this. And then so if you've done these or not, 0.0991, 0.0248, and 0.0027. Alright, so what is the probability that less than 4 stars were rolled when playing the die 7 times, or when rolling the die 7 times? So I'm going to write out my thing again. Again, so I don't want you to get confused what you actually have to write. All of these are the same. What do I know about all of these situations? I know that it is definitely what? Before that. Binomial. I know what else? I'm rolling it 7 times, and I know. And I can even write that my success I'm deeming as what? So if this were a test, I would need to see these with the problems, but since we're doing it for all of them, I don't want to write it out every single time. Alright, so these are my options. How do I write less than 4? I literally write less than 4, right? Just putting words and symbols. Up here, this is why I write this out. Which numbers are less than 4?
0.
So this is not what I type in. The last number I want is actually the probability that x is what?
X is less than.
Why do I care that I can write it this way or this way? Because this I can use CDF and this one I cannot. So you always want to try to write a problem in terms of a less than or equal to so that you can use that button. Now this is the same thing as saying I'm taking all 4 of those numbers and adding them together. I'm just not having to do it because the calculator does it for me. So now, type this in your calculator. And what do you get?
How do you, can we put less than 3?
No, so this is your CDF button.
So start
So-
with 0 and then do it.
So your X that you plug in is the highest
Oh,
one that is
right.
included. And what do you get here?
0.6531.
Which is the same thing that you would have gotten if you added 0.0199 plus 0.1044 plus 0.2350 plus 0.2938. So then here, which numbers are at most 4?
Zero to 4.
So how do I write that?
X is less than or equal to.
It's less than or equal to, which means I can use my CDF button. I know that it's going to be what in relation to this 65.31? I know it's going to be bigger because I'm adding more to it. Adding about 22 to it. Which gives me what? 87 what? This is the kind of problem where I think why I choose to write these out like this above it. So I know that I'm trying to find probability that x is greater than 4. We're good with that. So I'm going to circle the numbers that are greater than 4, which is 5, 6, 7. So these are what I don't want. So I'm doing the complement of probability of x being what? But if I said probability that they are at least 4, this would be greater than or equal to 4, and this would switch to what? Less than or equal to 3. So sometimes, like you see where this is the same number, but sometimes it's not, depending on if it's less than or greater than, that kind of thing.
Do the 1 minus part.
That's how you, like, so you actually type in this number and then 1 minus that. So like 1 minus what you get in your calculator. What you get in your calculator, 1 minus the answer. And it should be the complement of this, so it's what?
1, 2, 6.
So all that's left is that last child problem, right?
There's also
I would draw the bar graph for this. I'll probably include that because I want to do it as a lead in for tomorrow. In the next 10 minutes, I want you to do these first, and then go back and draw your bar graph. Just the inequality symbol, what does at most look like? Just an inequality symbol, what does at least look like? Greater than or equal to? And with this 0, 1, 2, 3, 4, 5, some of you are going to be like, I get inequalities, why do you want me to draw that? And I'm not going to grade based off of that, but if you write something wrong here, but you did it right here, and you mix up your thought process, then I can give you credit for it. And that straightens some people out. A, do I need to write anything else or go straight to my answer? Straight to the answer, because I already have it in terms of less than or equal to, which is what I want. And you get what there? And I don't have these in front of me, so let me know. Guess it's something different. Type it in exact like that, or do I need to write something else? So what would I write instead? Does it matter if I do equals or less than or equal to here? Because less than or equal to 0 is the same thing as equals 0. So now I'm going to type it in with equals 0 and then do 1 minus that, and I end up getting what?
7, 6, 3, 7.
I have an IGP.
Type it in or change it.
We have to change.
So I really want it written in terms of, because less than I can't use CDF. Yeah, less than or equal to I can.
Oh, why do you put like 0, 1, 2, 3, 4, 5?
That's if some people get like thrown off with the thought process. So some people, when they do,
No, I know why, but like, why isn't it just 1, 2, 3, 4, 5? So it's
Oh.
not shorter.
why isn't it just 1?
2, 3.
Okay, because I can have 5 children and none of them have type of blood. But that's a good question because that's a big thing with tomorrow. What I throw in is whether that 0 is there or not. So here I can do it 5 times and have no successes. Tomorrow that's a little different. And what do I get for this last answer?
0.6328.
Your graph itself should, we know it's going to peak where? At 3 because we showed that that's where it got high and then it started getting lower from there. In general, that's what your graph is going to look like, but with numbers and everything, but just making sure. So it's not perfectly symmetrical because mine might be shifted over 1. It should have room over here with a tiny bit of 7. There's 3, 4, 5, 6. There should be room for 7 up here too.